this video we'll see what is multiple bar plots, or how you can plot multiple bar plots. In particular, we'll see the Dodge approach, or the Dodge statistical transform, and the stack one. Then we will see the percentage stack, and how we can put additional dimensions, so have another dimension, and histograms. Yep, that's pretty much for this video. Let's get started. Okay, so we use the library tidyverse because tidyverse has ggplot too, so that is what we are going to use. And then this mass library has a dataset survey, so the survey dataset comes from mass and ggplot comes from tidyverse. Okay, so from there we are going to see this dataset for now, that is mtcars. Okay, so if I just tell you what it is, so it has the different cars over here, and it has the mpg of the car, the cylinder value, I guess this is displacement, horsepower, and etc. Okay, so how many gears you have and so on. Okay, so this is a simple data set that comes with R. Okay, yeah. Okay, so now if suppose we want to use a multiple bar plot, where suppose on the x-axis I have the number of gears. So here I have done factor gear. The factor basically turns the values in gear as levels. So just a simple example for that. So initially, if you see, gear is a double data type, but when you do factor, you get levels. So this is a level data type. Okay, so what happens is this has different levels, 4, 3, and so on. So it gives the levels, it identifies the different unique levels, so like 3, 4, 5, and then stores it as a level data type. Okay, so here we want to actually put levels. If you remember, in the previous video we talked about categorical data. So this in some sense is a categorical data, or this can also be seen as a numerical data with discrete data type. So you can have either categorical or numerical data with discrete data type on the x-axis, but just to make sure that it should have finite levels. I mean, suppose you have hundreds of levels over here, it'll be difficult to visualize the bar plot, right? So yeah, so they should have finite levels. I guess maximum would be, it depends on how big the screen is and so on, but you wouldn't want it to have more than maximum, I guess, 10, but depends. Yeah. Okay, so that is the x-axis. The y-axis is the horsepower. So we are seeing how much horsepower varies with respect to gears, the different gears. Okay, and here I've put a condition. So the condition is if cylinder is greater than 4. So there's cylinder as well. So if cylinder is greater than 4, you plot a different graph, and if it is less than 4, you plot a different. So see, here I've just put head of mtcars, so this will just plot the data for the first 6 rows. Okay, I've done this to explain you a concept. Okay, actually you need to plot for the whole data set, right? But then here I just want to show you something. So if you see here, my function, here my condition, so this is a condition. For that you need to give filter, so this is a short for filter, and then you tell what is the condition. Okay, so the condition is cylinder greater than 4. So if you see over here, uh, this value is less than or equal to 4, and other than this all others are greater than 4. Okay, so that's one. And the other thing is that gears, so you have gear number 3 and gear number 4. So you have gear number 4, the first 3 rows, and then gear number 3. Okay, so now if you see, I have put identity as my statistical transform, and my position is dodge. So by position, it gives me a side by side graph like this. Okay, so here I haven't got any graph because for gear 3, so this is gear 3, I hope you can see that. Yeah, this is 3. So for gear 3, you can see that there is no value for cylinder which is less than 4. You can see that here, right? So because of that, we have not got a bar plot for false, because everything is greater than 4. That's true. So everything is greater than 4 over here. Nothing is less than 4. Okay, the other thing is when gear becomes 4, you have one value that is 4 and the two values that is greater than 4. So one value that is 4 and the two values that are greater than 4 are over here. Now ideally identity initially used to be sum. So if you have seen my previous video, here I showed you that identity is nothing but sum. It sums the values over here. So if there are two A's, it'll sum 5 and 10, right? So this becomes 15. But then over here it actually works a little differently. So when you place identity, you can see that. So suppose if we take this, so for gear 4, cylinder greater than 4, gear 4, cylinder greater than 4 has these two values. The horsepower corresponding is 110, 110. So actually their sum should be 220, but then here you can see it is still giving you 110, right? So this can actually give wrong results, or this can give you something that is not actually required. Okay, so be careful. I would suggest not to use identity in this case for multiple bar plots. What you can do is you can use the summary and function sum. Okay, so that will help you better. Okay, so similarly you can see for the first case, so for gear 3, the horsepower actually is 110, 175, 105. So the addition of these will give you actually 300 something, right? So but here you can see it just shows you 175 probably. So what actually identity is doing, it is overlapping on each other. So the 210s are actually overlapped on each other over here, and hence you get just 110. So 110, and then over that it is overlapped as another 110, but this is actually not required, right? And then for this, all these three are overlapped over each other, and then the longest, that is 175, is just shown. So in some sense, in this particular graph, only the maximum value is shown. Okay, so I would recommend not to use identity for multiple plot. Instead, what you can use is the summary function if you want to do sum. Okay, so now this gives you the correct results. So this is like 220, that's what we wanted, 110 plus 110, and then this is somewhere 300. So you can see that this is somewhere close to 400. Yeah, okay, everything is the same. You can see everything is the same, just the statistical transform is something that have changed. Okay, you can also have mean over here. You can have any statistical transform that you want. So this will give you the mean horsepower. Okay, so this was the dodge position. What else you can do is you can use stack. Okay, so for stack, what happens is it stacks the values on the top. So over here, the same example, filter cylinder greater than 4 and less than 4 horsepower, x gear, x is equal to gear. So here, if I do position is equal to stack, what happens is, so for the first it is same, because for the first case, that is gear 3, I don't have any filter, that is I don't have any values less than 4. But then for the next case over here there is 110, 110, so that makes it 220, and then over 220 I have the 93. So totally this becomes 220 plus 93. Okay, but then this is how the stack works. Okay, here also you can have the sum, you can have mean, you can have anything. Okay, so yeah, so this is the stack position. It'll stack things on the top of each other. This was dodge. Okay, I know these names, and I mean stack is okay, but dodge is a little weird, but that's what R uses. uh, then what you can do is, suppose you don't want to actually give one condition but give more. So let me just remove the, so this is how you should actually use the graph, I mean ggplot. You should give the entire data set. So this is how it looks like. So here I've done factor cylinder as well. So cylinder actually has 3 levels, 4, 6 and 8. So here you can see for gear 3 I have 4, 6 and 8. For gear 4 I don't have 8, and for gear 5 I have 4, 6 and 8, and the different horsepowers over here. So there is one car, or there are a lot of cars. It is some, right? Yeah. So let me change this to mean so that it can be more interpretable. So for here I can say that the mean horsepower for cars having gear is equal to 5 and cylinder is equal to 8 as the maximum horsepower, or the average value of horsepower for uh, gear is equal to 5 and cylinder is equal to 8 is the highest. Okay, something like that. I mean, so this is very good for data visualization, gives you good colors and so on. So this is dodge. Similarly, you could have stack for this as well. Okay, let me just remove this head for now. Yep, you could have stack for this as well. So here it is sum, then you could also have mean. So like this you can actually vary the different parameters over here, and then have a good practice of ggplot. Okay, then you can have percentage stack. So with percentage stacks, every bar plot becomes 1, but then it's the ratio that matters over here. So the ratio of the different filters over here is what matters over here. So comparing this bar with this bar wouldn't be easier in the percentage plot, but then here you can actually see the difference between how much, say cylinder 6, how many cylinder 6 cars or how much horsepower do cylinder 6 car have in gear 3 versus how much they have in gear with cylinder 8 cars in gear 3, and so on. So for percentage you use the fill operator. Okay, so this fill is actually, this means fill everything. So yeah, so don't get confused with this fill and this fill, these both are different. Over here this means it is filter by cylinder, and this. Okay, again, I mean ideally you should have the entire data set. Um, so I'll just go through this. I guess I did not mention you. So for ggplot, the first variable is the data frame. This is the data frame. Then you have aesthetics. Um, you have you can give a filter option. You can give the y-axis option and the x-axis option. Okay. So yeah. So I actually explained the ggplot function in my previous video. So if you don't understand these things, you can maybe watch my previous video. And then there is the geometric bar for giving you bar graphs. Okay, then you can also add more dimensions. So say I so till now we have seen these things. Now suppose we want to add further more dimensions. Say I also want to add mpg. So that's over here, mpg. So you can do that by a facet wrap. Okay, I know these words are a little unintuitive. I'm not sure why these words are as they are, but then the facet wrap will actually give you another dimension, uh, mpg greater than 20. So what this does is it also separates the value that have mpg greater than 20. So these are greater than 20 and then less than 20. So mpg less than 20 is over here, mpg greater than 20 is over here. So that is also something you can add another dimension. Also notice this small tilde over here. So this is nothing but a symbol that is on the top of the tab in your keyboard, the tab on the leftmost leftmost side of the keyboard, or it will be uh, on the left of number 1 on the keyboard. So here if you don't put tilde, it might give you an error. So the tilde is actually to tell the data frame, tell R that this belongs to a data frame that is specified over here. Because you can actually also give something else. So say I have a variable over here which has these values. So I can also give a over here. So if you want to give something that is out of the data frame, then you just put it as it is. So a. So now this is actually uh, oh, so all my a values are actually less than 20. So it says everything is false. Okay, so let me make this less, suppose greater than 1. Yeah, so now I have false and true. So the first three go to false and the next three go to true. Okay, and then within that I have this factor as well. So if you want to give something that is apart from the data frame that you have used over here, then you just put it as it is. But if you want to use a column of the data frame, then you will have to put the tilde mpg. Okay, no, this should be greater than 20. Yep, and ideally, I mean, you will not use head over here. Yep, so this is how it works. So here I have stack, you can also have dodge. So that is dodge. Okay, so here you have an additional dimension like this. Again, this is preferred to be either categorical or finite discrete numerical data, I mean value type, because you will not you'll not understand if there are a lot of values over here, right? So yeah, this is also important. So for here, logical is extremely okay. So false and true, that is extremely okay. But the more you keep, it becomes difficult to interpret. Okay. Okay, then let's talk about histograms. So suppose you have, so this is the same data set. Suppose you want to actually plot a continuous data on the x-axis. You see here I used to always plot either categorical data or discrete numerical data on the x-axis for the bar plots. So if you want to plot continuous data like weight, so the weight is continuous over here, you can see that it shows this kind of a graph. Okay, this is very unintuitive because what it is doing it is plotting every number over here if it is different. So 2.620 is different from 2.875, so these two will have two different positions. So if you put, so here the mtcars has a lot of rows. So let us see how many rows does mtcar have. It has like 32 rows, so you will see 32 different values over here, which is actually not a good way to visualize this, right? So instead of using the bar plot over here, what you can use is you can use histogram. So histogram will actually give you bins, so you can specify how many bins you want. Say I want just 10 bins, so it'll group the continuous variables such that you just get 10 bins. So this is 1 2 3, so there are no variables or no weight in these two bins, so these are actually two different bins. 1 2 3 4 5 6 7 8 9 10, so 10 different bins are there over here. Also you can give a bin width if you know the bin width. So this is a bin width of 0.5. Okay, you can change the bin width and see what happens. So this gives you a bigger bin width, so this is a bin width of 1. Okay, so yeah, so you can play with this as well, and you can explore. Also you can see here I've just put one variable x, and on the y there is the count. That is how a histogram is. It has the frequency of occurrence on the y-axis and the count and the continuous variable on the x-axis. So yeah, so if you want to plot a continuous variable on the x-axis, you may want to use a histogram and not a bar plot. Bar plot, the x-axis should have only discrete, finite, numerical, or a categorical kind of a data. Okay, so that was all for this video. I hope you liked it. If you have any doubts, you can put them in the comments below and I'll be happy to answer them. Thank you so much for watching. Thank you.